Hello everybody, this is Itsu. I have got a lot of nice reaction on my multimeter AC test video I've done a few weeks ago. I've got one reaction with a question about using other waveforms to test. In the first test I only used sine wave, which is specified in the specifications of the meters, how it should react. But of course we have different waveforms like triangle and square square with the duty cycle, and they all have different crest factors and RMS values. So I'm trying now to see if my three multimeters I used before, how they behave in those different waveforms on different frequencies. And I will make a checkpoint of about 8 different frequencies, starting with 50 Hz and then going up all the way to 20 kHz. And I will note down the voltages by the 3 meters, the 2 multimeters and the analog meter, and compare them with the RMS value that should belong to that waveform. I will put it in some kind of spreadsheet, I think, later on at the end of the video. So the first waveform I'm using is again the sine wave, because I noticed that according to this Wikipedia document, when I have a peak of 1 volt, meaning peak to peak 2 volts, the RMS value will be 0.707, like mentioned here. So what I did is I put my function generator, which I'm used for this, I put it in sine wave, and it's at 50 Hz. You can also see that here. I put it peak to peak 20 volt, meaning I have a peak of 10 volts, so it's 10 times the value of the Wikipedia for better looking at it. The frequency is set to 50 Hz. So I have a nice waveform, and then according to this document we should have a RMS value of 0.7, because we have 10 times more. It should be 7.07 volt, but when I look at the RMS presented by my scope, it's less, it's 6.9. So I already have a deviation of what it should be according to the Wikipedia. But I'm just leave it that way. I'm not sure why, but the scope perhaps is also having some difference displayed, but it should be 7.07 according to the theory. Okay, well, I'm going to write down now the voltages on the meters. You can see that the cheap meter is a little bit lower, 6.56, and my analog meter is also, it's on the 10 volt scale, so it's the red trace, and it's about 6.7 volts. And my fluke meter is 6.58, similar like the other one. So I will start noting now this voltages for the sine wave up to the different frequencies and put it in a spreadsheet. Later on I will do the same for the triangle, the square wave, and I will see what I can do with this duty cycle type waveform, because I'm not sure. I'm sure that this function generator cannot vary the function, the duty cycle. It's always 50%, but I have a little Chinese function generator here who can do it, so I will try to do it with that test. So I will change now till I've got enough information for the sine wave, and then go to the triangle wave. Okay, so that was the first run. I'm now still at sine wave. I have my function generator at the highest value, 20 kilohertz, and you can see the completely wrong RMS values being displayed on the multimeters. To zoom in, I have a sine wave 20 volts peak to peak, which is 10 volt for one peak, and the frequency is 20 kilohertz, a little bit lower, and the RMS value displayed should be 7.07, but it's still 6.9 on my scope. But the values on the multimeters are way off. The LTPO meter here on the left is 20 volts displaying. The analog meter is displaying something like 1.7 volts instead of the 7 volts, and the fluke generator, the fluke multimeter is 4.4. So they're all three way off, and but they're all three way out of their specifications. So not surprisingly, they deviate. Okay, I will now change over till triangle waveform and do the same measurements. I include for measuring the peak-to-peak value, the theoretical value, and this what the scope displays, and then the 3 meters, and that I will present in a list for each sine wave later on at the end of the video. Okay, so here are the results of the first sine wave run. I make the graph of it, and you can see the clear deviation at the end, halfway through of the meters. I will present each time these figures after the run I did with each sine wave, with each waveform. So you can see the figures and a little graph how it looks like. Okay, there we are. Function generator put to triangle waveform. I've put it to the same 20 volts peak to peak, meaning 10 volt positive. Frequency is back to 50 Hertz, and the RMS value calculated by the scope is 5.68 volts. According to this Wikipedia document, the RMS value for a triangular wave should be 0.577 volt, but because we are 10-way multiplied by 10 of the 20 volts, it's better in line than with AC. It's 5.67. Okay, and I will now start the same range on the 3 multimeters. You can see that the meters are almost similar. 5.4 at this analog meter. So I will go to the same range as the sine wave and will note down all the values. Okay, here are the results of the triangle waveform. And also a little graph. It looks similar as the sine wave. Deviation halfway through the frequency range. Okay, continue now with square wave. Okay, and here are we at the start of the square wave run. Square wave put to 20 volts peak to peak, frequency 50 Hz, RMS is 9.6 volts. According to the theory, RMS should be 10 volts, as we use 10 volt or 20 volt peak to peak. Okay, I will start the run on the rest of the values. Quick look at multimeters. 10.23, the left one. Analog meter is bang on, 10 volts, and the fluke meter is 10.2 volts. So this is fairly in line with the RMS value. Okay, going to measure the rest of the frequencies now. Okay, this is the result of the square wave run, and also a little graph showing again the deviation from the theory via an equation. Okay, for the last measurement I will try to measure this PWM signal with variable duty cycle. I will try to measure duty cycle 10, 25, 50, 75 and 90% on the previous frequencies mentioned. I'm using for this my Chinese function generator, because that's the only one that can use variable duty cycle. So I've put it now at a 50 Hertz frequency to start with. I'm not able to get 20 volts out of this function generator, so I put it back to 1 volt peak to peak, just to simplify the calculations also. But I have some peaks on the signal, both positive and negative. So the peak to peak value is not accurate. It says 1.4, 1.5, but therefore I've put my scope to the half a volt per division, and I have a positive going pulse, 50% duty cycle at the moment, 1 volt positive. I use the offset of the function generator to get a positive signal, just like it is been seen here. And the voltage is also 1 volt, so we can use this calculation for the RMS, which is the time of the pulse divided by the total time. And if you look at now, we are at 50% duty cycle. It's also mentioned here on my function generator. The time base is 5 milliseconds per division. So the first positive pulse is 10 milliseconds, and the total period is 20 milliseconds. So when we calculate this, the square out of this combination, it's half. 10 divided by 20 is half, and then if you calculate the voltage, the root mean square voltage, it should be 0.707 volts. And that's also what is being shown here, almost a little bit more. So this is reasonably comparable with the 50% that should be in theory. When I look at my my meters, we directly on this low frequency have already a big deviation, 0.5, and this one shows I'm still at the 10 volt. But am I 10 volt, meaning the red lowest scale? So I am here at what is it, 1.2 something, slightly over 1.2 volts. And so that's also wrong. And also my fluke meter is not measuring the correct RMS value of this signal. So the next step I will do is go down with the duty cycle to 25%. Well, let me go to 10% and start from there up. So I'm 50 Hertz, 10% duty cycle. Signal looks like this. Duty cycle is 9.2% it says, and frequency still 50 Hertz, and the RMS is 342 millivolts. So this is the way I will measure it for the 4 different duty cycles. You can see that frequency is even lower. So I will put the figures on the spreadsheet, and you can see that probably this is a not very accurate way to measure with any voltage multimeter this kind of signals. I will now continue up in frequency up till the latest 90% duty cycle. Okay, still at the first run, 50 Hertz of PWM measurements, duty cycle 10, 25, 50, 75 and 90%. I've put the function generator at the last duty cycle, 90%, still 50 Hertz. This is what the signal looked like. It's half a volt per division, so we have 1 volt. And we are at 5 milliseconds per division. So when I calculate via this formula the RMS, it should be 0.94 volts, and this is close what the scope is showing, but all the multimeters are way off, and that's for the whole range already with this low 50 Hertz frequency. So none of the meters is capable of calculating the correct RMS value of this kind of pulse. Okay, continue now with the next 100 Hertz frequency and then the several duty cycles.